Okay, this video is going to go over the transformations and similarity cheat sheet that we're making in class today. And I'm going to skip this top part because it talks about similarity and changing dimensions specifically. So what I'm going to do is I'm going to start with all of the transformations. Remember, transformation meant to move. So in each different transformation, the first point tells us how this transformation means to move. Remember, translation means to slide, reflection means to flip, rotation means to turn, and dilation means that it's a size change. Now, it's the only transformation that changes size, and because it's changing size, this is not congruent. Dilations are the only ones that do not preserve congruence. Okay. So after we discussed how the transformation meant to move, we started talking about an algebraic rule and also just how to do the slide or the size change, flip, or turn. So I'm going to focus mostly on translations right now. Translations was the only rule that you'd used adding or minusing. Remember, if you were going to go up, you added something to the y value, and if you were sliding down, you minused something from the y value. If you were sliding right, you added something to the x value, and if you were sliding left, you subtracted something from the x value. So as an example, if we had a rule, our normal ordered pair xy transformed to x plus 2, y minus 6. This would be a translation that goes right twice, plus 2 on the x, and then this changes the y. So on the y-axis, a minus means down, so y minus 6, or down 6. Okay? Now that's the rule, so x plus or minus some number, we usually call it a, and then y plus or minus some number, we usually called it b. That was the general rule where a and b are just in place of numbers. X and y tells you which axis you're moving on. The plus or minus tells you which direction you're moving on that axis. Now, how to do the translation? Well, you put your pencil at the pre-image point, so that's something like A, and then you count left or right, or you go, and you might also have to go up or down, depending on that rule, and that would get you to the image A prime. Okay, so that was translation. It was just a slide. Dilation was a size change. So the image, remember that has the apostrophe, is similar to the pre-image, which means the sides are proportional and the angles are congruent. Now the actual size of the shape itself is not congruent. Dilations do not preserve congruence, and it's the only one that does this, or I guess does not do that. Okay, there are two types of dilations. If you change the size in a way that makes the shape bigger, we call that a grow or an enlargement. Remembering what large means bigger, right? Now that only happened if the scale factor, k, was bigger than 1. So then if you had a dilation that didn't get bigger but it got smaller, we call that a shrink or a reduction, reduce. And that only happened if k was smaller than 1, if the scale factor was smaller than 1. Now this was the only rule that used multiplication with actual numbers. All you had to do was take x and y and multiplied them by the scale factor k. So it looked like k times x and k times y. Now remember, you can type in k times the ordered pair on Desmos to find the new ordered pair, so you don't have to do the multiplication. The online calculator will do it for you if you type it in like this. Okay, the way you get the new one is just by multiplying all your ordered pairs and then plotting them. So the rule is your kx, ky stuff, and the how to move is just by multiplying. Dilate means to multiply. Translation means slide or to add and minus. Reflections and rotations. The rules here dealt mostly with sign changes, and you might have to switch the letters if you're dealing with a rotation as well. Let's start with reflections. A reflection just uses a single one sign change, and the letters stay in the same order. So you can have x negative y, or you can have negative x normal y. So we said if we flipped over 1, the other sign changed. Flip over 1, change the other sign. So if we flip over x, then we changed y's sign. So x negative y means we flipped over the x. Flip over 1, change the other sign. So we flipped over, x got changed, which meant we flipped over y. Flip over y. Okay? So that's the rule. You have either x and y, no matter what, are in the same order, x then y, but there's one sign change. The sign change tells you didn't flip over that axis, you flipped over the one that stayed the same. Flip over 1, change the other sign. Flip over 1, change the other sign. Okay. Now, in order to actually put the reflection on the graph, you started at the pre-image. So from the pre-image, something like A, you first counted to the line of reflection, count it 2, and then you count that same number away from that line. And then that brings you to A prime. So you count from A, count it to the line, then count it away from the line to get to A prime. Okay. Yep. Now we're on rotations. Rotations. To get the rule, you have to label the axes of your graph. Label the axes. So that's labeling with a positive x, positive y, negative x, negative y. Okay. And then you turn your graph, and to get the new x value, you read what's pointing to the right. Now to get the new y value, you read what's pointing up. To get the rule, you label the axes, then turn that graph, read the up, read the right, read the up, then we laugh. I think that was what was in the wrap anyways. Okay, sorry. So you're going to take your normal graph, and you label it positive x, positive y, negative y. And then if it's a 90-degree rotation, you would actually turn your paper 90 degrees, read the thing pointing to the right, y, read the thing pointing up, negative x. So your new rule would be y, negative x. If it was a 180-degree rotation, you turned it twice. Oops. Read the right, negative x. Read the up, negative y. So the rule would be negative x, negative y. Okay. Let's review what clockwise meant. Clockwise meant it was a right turn. It was going the same direction a clock did. Counterclockwise meant it was a left turn. So opposite the numbers on the clock. 90 degrees was one turn, 180 degrees was 2 turns, 270 degrees was 3 turns. In 8th grade, we'd only turn in increments of 90, right? So first you're going to, to actually do the rotation, first you turn your paper, then you read the new ordered pairs. These are the new ones. After you turn, you're reading A prime, B prime, C prime, all that stuff. Then you turn back to normal, and then you can plot the ordered pairs. Okay. So that is all of our transformations cheat sheet. First, how it moves. Then how we get the rule. And then how to actually do the transformation here. Okay, each box is set up like that. Looking up at the top, this is what we started talking about more recently. We use dilations to change a picture, usually of a rectangle or a triangle. Okay, and when we did that, all we did was multiply, right? First, we had to know SF or K. That meant it was the image, which is the new thing, over divided by the pre-image, the original thing. So to find the scale factor, you're doing new over old. I'm putting the apostrophe by new because the new thing, the image, is the thing that has the apostrophe. Okay. We remembered, we said if we don't know the scale factor, oh no, we have to divide. Okay. Remember, to find perimeter, you just add all of your sides. And if you want to find the new perimeter, so if you've dilated a shape, instead of having to multiply all the new sides and then add all the new sides, you could just take the original perimeter and multiply that by the scale factor K. All right, so just a friendly reminder, that's how you find the area of a rectangle and a triangle. So if you have the area of an original shape, but you've dilated it, instead of having to use the formula again, you could just say the new area is going to be the original area multiplied by the scale factor squared. That's the original thing times K again. So that's our cheat sheet for transformations. Oops, that's not my one. How would I stop the recording? Oh no. Okay. Mark that away. Oh. What's happening? Fans, I would like to just stop the recording now. Oh no.